Hi guys, so in the previous video we stopped here. We found the distances and now we would like to find the minimum distance. Why is that so? As I told you in the previous video, we're gonna have a store of all the distances, yeah? And then this point, this vector, atom, this entity will belong to one team and one team only, to one cluster and one cluster only. And the rule for that is that it is the minimum distance. So over here, I'm gonna find the minimum distance. So here, I'm just get minimum, yeah? And let's put here the minimum of all of these. This would be the minimum distance. And now, you know what? I like neat situations. So I'm gonna just put here a very neat line to separate the distances. You see that? You don't have to do that, but I put this line to separate the distances from the minimum distance. Which one is the minimum distance? You can find it through the minimum function on Excel and then drag it all the way until the end of the data set. This might take a while. We have quite a number, I think about 100 clients. Okay. So now we found the minimum number. This is just the minimum number. In the future, when I have these populated with numbers, the thing would be, you know what? The thing would be that this number, I have to look into with my mere eyes and see which cluster it belongs to. I don't have to do that. I can automate it. I can ask the cluster that it belongs to. So there is actually a very interesting function called the match function. And this match function takes the following arguments. The first one is the lookup value. The lookup value is this value. I want you to look up this value for me in this range, in this lookup range, and tell me which cluster it belongs to. Meaning, I want the exact match of which position, starting from top to bottom. So it's always important, guys, that you start with the distance from centroid 1, not centroid. You say, you know what, I'm going to start distance from centroid 5, 4, 3, 2, 1. Well, then you have to change this. Yeah, it's going to be difficult for you to utilize the match function. So the match function will return the first entry that satisfies the match. The first entry that exactly satisfies the match. Okay, so over here the first entry is 1. For all of them it's going to be 1 because the numbers, as you can see, are all similar because we don't have any numbers populating the cells into the centroid vectors. So over here we just drag all the way. And as I told you, all of them, I expected them to be 1. So now I knew which cluster each client belonged to. Because maybe this client, along with this client over here, belongs to cluster number 3. So they are not very adjacent. They shouldn't be adjacent necessarily, right? Okay, so now, excuse me, we are ready to to do the second step of the iteration. The second step of the iteration, after you identify which cluster you belong to, this centroid position will change based on the minimum sum of all these distances, based on the average. But the average is the sum over the number of points. So basically, we can say that here is the distance, the sum of distances from centroid. So you know what, I'm gonna put this back here and I'm gonna put it as bold, and guess what, I'm gonna in fact highlight this with a thick outside border, as you can see here, and this will be the sum of distances from centroid. In my slides, I think I have it somewhere here back in the time, but I find it to be more neat to put it here. This will be the sum of the distances. And in fact, if you want even, you know what, a better arrangement, I have a better arrangement in mind. Let me take this. I'm going to put it somewhere here. You know why, guys? Oh, no. here. I'm going to put it somewhere here. And actually this here. I'm going to put it somewhere here because I'm going to take the sum of all these minimum distances. Yeah? Because these are the distances from the centroid that it belongs to. So the sum of all these minimum distances will give me the rule when to stop, when the iterations will be over. The iteration will be over when the average, which is the sum over the number, the average, which is the sum of all these minimum distances, and I'm gonna just click on one of the cells, hold down the shift key with my thumb, and then hold down the control key with my left thumb, and then use my left index to hold down the shift, so control shift, and then use the arrow over here and hit enter, and this will be the sum. Technically we need the average distance, which is this sum over the number, which is 100. But when we are going to optimize to find the minimum distances, the number in the numerator is going to be constant. It's always going to be 100 clients, right? In total. I know that in the presentation, in the previous video, I talked about minimizing the sum of the distances within the cluster. But it is the same thing. If we minimize the number of the distances within each cluster, that will also yield to the minimization of all the sum of the distances in general. So we want to minimize this. So far, if we position randomly all the centroid in vector 0, 0, 0, 0, 0, 0, 0, that will be the distance. If we position it differently, then we will have a different number over here. Now, I don't know, let me just set up the solver, the optimization problem, but I need to explain a little bit about the optimization problem for you. I think I gave you enough probably for today's lecture, because I know some students are probably not very familiar with Excel, so maybe whatever took me 1 minute, it might take them not only 1 minute, but 1 minute and a half or 2 minutes to figure out. So let me stop here, because the next step would be explaining what is an optimization problem, what is its components, and then you need to go to Excel. But please do this before you leave me right now. Please do the following so that we can maximize our time in class. I would like you to go to data and check if you have solver. Do you have solver under data? If you don't, no problem. Go to File, go to Options, and for Mac users, please look it up on Google and let me know if you desperately don't know how to do it. Go to Add-ins, go to here, Excel Add-ins, and go, and check Solver. I recommend that you check Analysis Toolpath if you want, but I'm just gonna put Solver for now for this class. So this is for Solver. And now you will have solver. If you look into solver, you will see that there is an objective function here. You will have the optimization problem to maximum, minimum, or a certain value. Changing certain cells. These cells are actually the centroids. We keep on changing the centroids, right? We keep on changing the centroids until they are on the average, and until the average distance between all the data points is to the minimum. So we are going to set up this objective function next class together, because this is the difficult part, and I will see you in next class then. So today you learned a lot of skills with me. You learned how to create a pivot table, which is a table that gives us the count or the average or the sum. We used the count here of the clients and the offers. Then we used the same table over here, and we added the centroids or clusters here. And we use the distance between a vector that represents a position of the centroid in a cluster 1 and the vector that represents the transactions or the offers that each client is interested in, and it is signaled by 1. So this means that Adam is interested in offer 18 and in offers 29 and 30. So we are finding the Euclidean distance, and Euclidean distance is the square of the sum of the squared difference. And because this is not a usual point by point, it's an array by array, we are going to use Control Shift and Enter with Excel to signal to Excel that this is an array function. So this is all what we did today, and I know that most of you know the minimum function in Excel, and then maybe the match function you didn't know about it, but there's a good explanation of the match function here in the slides as well. So the match function basically assigns the cluster. The match function searches for a specific item, a lookup value here in the first argument in a range, as you can see here, and then returns the position of that item in the range. So your position is number 1, 2, 3, 4, 5, and this also reflects 1, 2, 3, 4, 5 centroids. All right, lovely people. Next, we also set up today what we call it the objective function. It's a function. Sum is a function because you are summing this plus this plus this plus this plus this until the end. You are summing all these minimum distances. So your objective is to minimize this distance, to keep iterating until the distance is minimized. Next time, I'm going to talk more about optimization problem, definition, and we're going to run the solver to optimize our problem and find the best arrangements using the k-means clustering. All right, lovely people, I'll see you in the class on Tuesday. Enjoy the weekend.